So thank you very much for having me today. With this presentation, I'd like to give you an impression on how we at Vector use Rust for our automotive applications, and why we actually think that Rust is the future for automotive software development. Before we dive into the technical details, I'm pretty sure Vector is very well unknown outside of our automotive industry. So who doesn't know Vector already? Oh, that's even 60%, I think. Thank you. So I don't need to say a lot about Vector, but very briefly, we are an automotive software company. We're around there for more than 35 years. And my focus is actually within Vector on the embedded software that you don't see in a car, right? We don't do the fancy IVI stuff. We do the software that no one's aware about it. So let's have a dive into what is large scale. What do we mean by large scale? And we immediately see that there are different dimensions on this kind of large scale. First, number of developers, right? For our core products, two of them, we roughly have 630 full-time equivalents working on it, with around 500 people doing the tools around it and providing services. Working? No. Then this way. Size of the product is another one, like another dimension of the scale. We have two products, basically, one in C and one in C++, roughly 1.2 million source lines of code, so without any comments and empty lines measured. Okay? The C++ is astonishingly twice the size almost. And the last dimension is also its use. This is a very rough estimation that we're running on more than 10 billion ECUs in basically all kinds of vehicles. So I like the expression most that if you go on the street and you see a car, you can bet there's Vector software in at least one of the ECUs there, and you'll never notice. And like, if you think this is impressive, the more impressive thing is, to me at least, that in the past 20 years, we've never been responsible for any significant recall from the field. So this is what we mean by large scale. And my idea is that we put Rust, at least at one point in time, in that scale. We're not there yet. So let's talk about automotive. How many of you are working in the automotive industry? Oh, that's definitely less. That's like 20% audience. Thank you. Because how hard can it be, right? We have other industries that produce safety-related software, like aerospace industry, industrial automation. True. And it is very often said that automotive industry suffers from the not invented here syndrome, right? I guess we all do very often, and I absolutely partly agree with this. But let's have a look at the table further on. There's also other high-volume industries, right? I learned that like game consoles, like there's 40 million pieces a year, right? Like these things, I guess even more. I've not checked it, but there are other industries that produce high volume. There are other industries where you have distributed systems, so where your calculations is not done in a single computing node, but in multiple. So even aircraft and the internet, as it is a distributed system. And of course, hard real time. Whenever you control something that is connected to the real physical world, it's basically something that gets down to a hard real-time problem. Because you could argue computer games, they also need hard real-time. Yeah, but what happens if you miss your deadline in a computer game? You get a glitch, you get some not so fancy graphics, but nothing happens, right? In things in the physical world, you really have an effect. And something that is very often forgotten, and because automotive industry is very good at that, automotive industry is a regulated market. There is at least more than 80 different regulations for just building a car, starting from simple things like direction lights, right? Highly regulated how they should look like. And this is just for the purely automotive-specific things. Whenever you build anything that is hardware, there's a lot of other stuff you need to take care about, like EMC compatibility, materials, and so on, right? So I'm partially really glad that we just do software, and there's far less regulation on that. So to me, the automotive industry is special just because of this kind of unique combination, right? You have a very high cost pressure due to the high volume. Nevertheless, you try to build safety-related systems, safety-related in terms of if anything goes wrong, if there's a fault in your system, there's a potential that someone can get hurt. And yeah, I think that's, now we've covered the automotive, the large scale. And yeah, so we are at Oxidize, so I think we need to talk about C and C++, right? As I already mentioned, our current products are in C and C++. We have a very good understanding on which activity in our development processes does cost us in terms of effort, how much. Okay, so we have a very good estimation. So the left bar is something we really have very well understood. So we sat together and tried to project this into our future Rust usage. And I picked some highlights to the right, where we expect to save a tremendous amount of effort. So first thing is in the implementation. Why? Because Rust is a very expressive language, and I've read that and heard that like at this conference twice or 3 times already. We're getting a big step closer to if it compiles, it works. Right? Static analysis, we are spending a lot of effort in static analysis for C and C++. For C++, it's even harder than for the C part. And with Rust, we are actually anticipating just using the Rust compiler, which gives you a very good indicator on what you did wrong with its elaborate diagnostics. And Clippy, adding some custom Clippy lens, but that is our current goal to use, and that reduces the amount of effort we need to put in static analysis tremendously. I think it's just this big number because we completely removed that for the Rust side. We're not doing only static code analysis, but we are pushing one step further, also implementing a semantic code analysis in terms of abstract interpretation against memory corruptions. And we will completely remove that because in safe Rust, you got that intrinsically from the programming language, right? You still need to think about unsafe, of course, and we need that unsafe because we're doing an embedded part. But this is a minor thing we can completely remove, and there's currently still a lot of effort going into. Then the review part. Rust is so much less complex than C++. I every day learn something new about C++ I was not aware about that can go wrong. And believe me, if it can go wrong, it will go wrong at one point in time. So you will see I'm not a big fan of C++, actually. I admit. Then testing. The testing framework in Rust is extremely good. It's built into the language. You have best practices, where to put the tests. That's why you save some time, because it's very natural to write tests. It's very easy to write tests. you don't need additional code. Nevertheless, you still have generics, you still have polymorphism as in C++. And for those, you need some kind of special techniques to sufficiently cover them with tests. Right? Because especially we are working in a safety domain, we are really concerned also about the edge cases that can happen. So this was from an engineering perspective. If we zoom out, we actually see and consider a different effect, and that is, and I think we heard that yesterday already, if we have programs that come out with a very high quality, you automatically spend less time in debugging and support sessions. Okay? So in total, we expect to get to be 20%, roughly 20% cheaper in terms of development cost than we are today with C and C++. I said this is some kind of expert judgment. Currently a guess, an estimation, let's put it this way, an estimation, and maybe I can tell you in 2 years how good our judgment was. If you're interested in more details, have a look at the article we wrote together with Ferris on an overview on how we currently think the Rust ecosystem looks like, where we actually also have those numbers in there. So point is, it gets cheaper to develop automotive software, and that is key currently. So let's jump into our technical opportunities. Why do we think that Rust is actually, from a technical point of view, the future? Of course, first, it's a type system, yeah, right? Borrow checker, there's nothing new. You're all familiar with Rust. I don't tell you something new here. For us today in the C and C++ world, the hardest part is avoiding race conditions, right? We have tests for the functionality. We have a semantic code analysis really going in depth to avoid this out-of-bounds accesses. But we're still, because untestable is the race conditions. And this, if you stay in the safe Rust subset, completely avoid it. Okay. And as that, static analysis is getting cheaper just because it's part of a normal compiler run. What Rust also did right, very right, if you can say that, is consistent error handling. Especially without exceptions. One of the few programming languages without exceptions. I hate exceptions, I'm sorry about that. We tried to avoid the problems of exceptions in our C++ product and actually introduced the result type based from, like we took that over, but the result type is just half of the rent if you don't have the question mark operator. Nevertheless, this is one of the things that is really good in Rust. Next thing is we are building software products that work on very small microcontrollers and on high-performance computers. For all of those, to get high performance and to get this high performance scaled down also on the smallest microcontrollers, you need zero-cost abstractions because that makes Rust, to my understanding, the only truly scalable programming language that can be used across different powerful domains. And one of them is, for instance, the type state pattern, where you can get a deadlock-free guarantee at compile time. There was a very nice talk on last year's RustConf, I think it was Google, on their Fuchsia network stack. We partly introduced that in our future Rust products already, and a colleague said it is very easy to introduce, very small code you need to introduce. can introduce it step by step. So this is another real benefit of the Rust programming language. Then async. You could say, okay, why async in such a world? If you look into our current C and C++ products, what we mainly do is implementing the state machines that you get in async for free. Because what our products do is like we do implement network stacks, we do implement memory stacks, and all of them are basically doing I/O, and you need to wait until this I/O is finished because of the slow hardware. So basically, async is what I think is very suitable to use in this case. And I yesterday learned about the project Copper, right? Very nice thing. Have a look at it. And then we yesterday also heard a lot about, we use CMake and so on, but CMake is build system. And that, I don't think the comparison to Cargo is actually fair, because Cargo is not just a build system, it's a package manager, right? And that is nothing what CMake is alike. And this kind of package management system, even though you will need proprietary crates or proprietary registries and not just crates.io, if you have this kind of, or a product or an ecosystem for qualified software, you might have completely closed source projects in certain industries, so you need this kind of private registries. But then you still get all the benefits of Cargo and its package management system, right? It's not only a build system. I would love to tell you that our colleagues just exclusively use Cargo, but they actually said, yeah, we have still a lot of things around it in C and C++. So we need something on top to build all of it, to make the whole thing working. So that's why you still need some kind of system like Bazel or anything like, for instance, also CMake around it. So that's why we think it's a good thing, and why we think Rust is the future. But now let's talk about why we think it still needs time, and it's really a matter of time. Automotive industry, high volume, high cost pressure. And sometimes you pick controllers that might seem exotic to the world, but that are cheap. And so we have a very common microcontrollers, like the Tyco Oryx, which is not one of the cheap ones, but the most prominent ones, as well as Renesas RH850. One of the breakthroughs that was where I thought, yeah, it makes sense to start pushing Rust into the automotive industry when there was a compiler available for the Tricore, a Rust compiler available for the Tricore. There is still no one available for the RH850. And we have other platforms. I mean, ARM is on the rise, right? So there's many semiconductor vendors putting ARM, Cortex AEM-Rs in there. Which is good because there you can use Ferrocene or the standard Rust compiler. But we are still lacking some of the what seems to be more exotic ones, but are still used or are used in the automotive industry. And we need them to build products for the automotive industry. That is a solvable, right? Then, code coverage. Yes, we have LLVM-CAF. LLVM-CAF is already providing very good statement coverage. It even gives you a statement coverage per instance of a generic function, whatever you have. Nevertheless, there are a lot of studies telling you that statement coverage is basically not a real good indicator for software quality, so you need much more stringent metrics for this. There's this efforts putting MCDC coverage in Clang. And you might know that we are also a provider of code coverage tools. And I got the OK from the colleagues to tell you that by mid of next year, we will have a first version of our next generation coverage tooling that will support Rust in kind of development mode. But to me, this is really good news because that is something I absolutely rely on for our products, that we can have that in future. Then, of course, we are still lacking the qualification of standard library, core library, and other very essential crates. But to me, this is rather a matter of time, right? This will evolve based on usage of Rust that we get there, that we get qualified versions from it. That may not be the upstream versions anymore. That might change versions, but that is something we'll see how it will work out. But I'm pretty sure we'll get that. And then some not so urgent topic, but something that is, if you develop software on that scale, nonetheless important, is you need to get a grasp on how big, how complex the thing you built is actually is. In our argument for safety of our software, we very often need this kind of complexity metrics. And yes, we have cyclomatic complexity. Cyclomatic complexity would also work for Rust, but Rust introduces some new concepts. Traits are not pure virtual interfaces in that kind of sense, and there's no real consensus yet, and I've not even noticed any kind of discussion on how metrics could look like. For C and C++, we have very well-established metrics, even numbers for their limits that are generally accepted, even though they're just wild guesses again. We need that in future for Rust too. But again, this is not so urgent topic, and I'm pretty sure we'll solve that too. When having reviewed those slides by my colleagues, one comment came more than once, and that is, oh, we need to ramp up developers. Yes, we need to, but this is not a problem of Rust. Because whenever you need to learn a new technology, you need to ramp up developers. So that's why I didn't put it on the slides, if you missed that. So now let's step further into the future. As I said, we currently have two main products, one in C and one C++. Basically, the C one is more on the microcontroller side. The C++ version is more for the microprocessor side. So if you want to use Rust right now, you can always use BindGen, right? We have actually described in our knowledge base quite elaborately how to write Rust software components for our current stack. So this is fortunately always possible. We are currently having the colleagues implementing a more idiomatic and native Rust interface generated so you can write your software components for our products in safe Rust without creating those wrappers on your own. There we have a first version available, hopefully within this year. Actually, that's the plan. And for next year, we will have Rust support in our C++ project. We took the detour around C. We had long discussions about it. We've also yesterday learned about this kind of interfacing with C++ and C. We decided to go for really taking the C detour because we're not handling the complex types at those interfaces, actually. We try to put them in the Rust world again, or in whatever is on top of our C interfaces instead of Rust. So, and that, like, should we think further than 2026? Most probably. At least to me, it would be very great, awesome, if we have a single scalable solution, because I already said I'm convinced that Rust is the truly only scalable programming language. That we, at one point in time, have this kind of single scalable solution. Can't tell you if and when we will have that. But that's at least my vision for this. What I can tell you is that we are actually working on bringing Rust in the automotive industry and others. And that is that we started developing a deterministic high-performance async runtime for real-time systems. That is deployable on microcontrollers and microprocessors, because we expect that automotive systems are still distributed, and other industries also have these kind of distributed systems. And to get timing right, and that is something no one can do really good today. And we just try to give them another approach here. You need record and replay features for the distributed systems. And we actually want to ensure this kind of end-to-end latency for your applications, because that's what you need in cyber-physical systems, that you can ensure, even with some kind of safety guarantee, safety in terms of no one's getting hurt if there's a fault, for your system. So basically, we're building a Tokyo for the safety-critical distributed cyber-physical system. And why do we think we can do that? Because Rust enables us to build exactly this kind of reliable, scalable software for tomorrow's systems, cheaper and faster. And with that, I'm really looking forward to your questions. Thank you.
We have a question back here first.
Hi, great talk. So going back to one of your first few slides, you said that you feel that the Rust compiler warnings and errors are, and the Clippy warnings are enough for static analysis. How would you see MISRA Rust play into this? We talked yesterday quite a bit about MISRA Rust. Would this be a special profile in Clippy, or?
And actually, I don't know what MISRA Rust should be. The only publication I know from MISRA is that they've created a mapping of MISRA Z rules to what would be still applicable in Rust, right? That is the only thing you get currently from MISRA. In terms of coding standards, then actually that is basically more in the direction. And if you read the article we've written, we dip into this area. I hope Christoph will make it possible that we once have the SAE-J 1020, which gives already a very good guidance on this. Then there's the Safety Critical Rust Consortium, where we also contribute parts of our coding standard we have at the moment into. And that's why I said, yeah, Clippy, maybe some custom lints that Clippy has, but that's what we today see.
Okay, I can ask one more question. So you also mentioned that Vector is working on their own code coverage tools, which you already have some, of course, but for C and C++, so you're working on bringing them to Rust.
Yep.
And I'm wondering, since the Rust community takes this more open approach where the tooling is centralized, there's also some merge requests and some efforts to bring, for example, MCDC coverage in the compiler and in the toolchain directly. Why take an approach where you're building your own castle again, instead of working with the community in the same toolchain and the same environment?
I had the same question to the colleagues. There was a simple answer. And they said, if you put effort into the Clang infrastructure, which is basically what Rust builds upon, you lose a lot. Because there are other compilers, a lot of different compiler vendors still. You've seen them around here. There are other architectures that will never be supported by Clang, that are used in those industries that actually care about qualified tooling with a very stringent coverage metric. Okay, and then if you see it from this perspective, it just makes sense to build Rust as an additional package upon the own infrastructure we have. Yeah. Unfortunately, it is that way. Like that is like I'm a bit split here, right? Because from a company perspective, I can totally understand that approach. From a personal perspective, where I'd like to also have this kind of thing as open source in the Rust ecosystem. Yeah, it's a pity, but we do.
Okay, we've got one here and one there, and then I see.
Yeah, my question was already just asked, so I'm just going to leave a remark. You said that we have this trouble with the coding metrics, that we don't have them for Rust. I don't know what your opinion is of the coding metrics that we have for other languages. I think we also have a problem there. I don't like them very much. But I just wanted to mention there is actually in MISRA right now a working group that is looking at coding metrics and thinking about maybe publishing a new document there. But they are a little bit short on manpower. So if you have people inside Vector that are interested in metrics, maybe reach out to them and see if you can contribute.
A very famous and loved topic, metrics, of course, right? The point is, I don't see that it's that the big problem. Where I see a kind of difference is that there has at least been some kind of discussion for other languages. You can agree or disagree with those metrics. We partially also disagree on the numbers that the other people found. But there has at least been some kind of discussion that I've not seen in Rust yet.
Here, Jonas, thanks a lot for the presentation. So how, based on what you said, how does Vector transform? So you gave now a bit of a view how outside, for the product's perspective, you like to change, but what does it mean internally at the end? So how do you convince Matthias Traub, Jochen Rein and the folks that this is the right direction to go? How from an organizational perspective, investment perspective, you transform Vector that this vision can get through?
Actually, it was quite easy, right? Because one of the benefits I think Vector has, one of the main assets is that up to our CEOs, they have understood extremely well what software development actually means. And that is what we have as kind of an advantage in contrast to other tier ones where the management is like coming from a mechanical background. So convincing them was actually fairly easy. Transforming is another thing, because for those products we currently have a lot of orders, we have a lot of big feature backlog still, and we need to still support them for a long time. So parts of this code is like really 35 years old. Okay, and the thing I've noticed is that we have started with a small group in doing like our new products in Rust, and they're really happy with it. We have a lot of interest from the colleagues still need to maintaining the current products, switching over to Rust. So they on their own say, oh, I want to do this, because they also see the benefits of Rust. And sometimes we need to just like calm them down and say, yeah, if we scale that up and if it works the way we think it works, and if it's successful, we'll probably shift. But for now, it's a rather small group with respect to the number of people I've shown you that is currently doing Rust development. But from a transformation point of view, I don't think that there's really a problem for us, because really people all colleagues are really keen on using Rust, just on their own.
Thanks. Then we have one more. We have two more questions. So here.
Actually, I have to. But first, I'd like to thank you for kind of answering my call, Russ, from last year about showing in solid numbers. what going into Rust means. That's nice to see. But I'd like to understand one thing more clearly from these numbers about shortening the development time, engineering time, let's say, because we're taking all the aspects into account. How these numbers includes actually working on anything that interoperability between these two languages. So it's still getting something shorter, even if you still need to work with C++ somewhere in your code. And the second question, you mentioned the closed source access to other proprietary registries. Does it mean that you kind of solve the problem of how closed source can be developed, or you mean closed source by the license means and it's still and somebody's register with the access control where you effectively still pull sources to build yourself?
Yeah. So let me try to answer the second question first, because I'm not sure I got the first one right. Our products are delivered as source code. So basically, you could say we are open source. The only thing is that we have a commercial license attached to it. Okay. You get the license to change, modify all our code once you've bought such a license with the restrictive, or like with some kind of restrictions to your project or the scope we actually agreed on. So yes, this kind of closed source was more, either you do really closed source applications for your products in terms of, I can imagine defense applications, they would never like to use crateIO, right? And they need to have a means of managing and using the advantages of the cargo or the package management, even within their own company, possibly air-gapped, right? And that is where you need this kind of proprietary registries, just to take the kind of advantage of it. And I can think of that this might be one way of distributing our proprietary software even in future to our customers, even though it's then also the source will be available to our customers again. But that's not decided on yet how.
So, last one here.
Could you go back to the first cost-saving slides? Because you claimed that Rust was a lot simpler than C++, hard to argue about that. But then you had a 5% cost saving on, I think it was, review. That seems then comparatively small. Could you tell a bit more about that? Is that maybe because Rust is new and there might be, a bit more of an initial startup phase and this might increase further in the future? Or are Rust reviewers maybe just more expensive?
Yeah. So why just 5? The question is basically why just 5%, right? If Rust is that less complex than C++, as I claimed. The point is, we built upon a lot of human intelligence reading that code and answering a few questions like consistency, completeness, right? Which actually today no one apart from a human can actually answer, right? I don't trust AI at the moment, and I'm not sure if I will do in future. But this is something you have to do as a human, and this will not go away just by using a different programming language. So even if it's just 5%, you might get an even better result from the review itself, because people can focus more on these kinds of questions than on the actual intrinsic complexity of C++, where they need to try to find some kind of bugs that still no compiler tells you about. Right, so I don't expect less effort, but a better quality from the review. Exactly, but this is just about effort. This table was just about effort, so I don't think that we didn't reflect the quality in here. Yeah.
Okay, thanks.
Then just one word. If you'd like to have the links that I had in my slides, I can give that afterwards. Thank you.
Thank you, Jonas. I saw there was one more question. I'm so sorry, but we're going into the coffee break, so catch Jonas there. And Jonas will also be joining us for the safety critical panel at the end of the next session. So we'll see each other again at 11:15. A reminder, lunch won't be until 1 p.m. The website has been updated now with the schedule. The schedule that's going to be running on the screens is still the old one, but have a look at the website, and we'll see you again at 11:15. Thank you.